let's practice this idea that the bounds of R might not be constants now, but might be given by functions instead, by looking at the following example. I'd like to integrate f of x comma y equals root, inside the root, 4 minus quantity x squared plus y squared over the region enclosed by r is equal to 2 sine theta, but for which values of theta? For theta ranging between 0 and pi, excuse me. So this all on its own looks a little funny. And so before getting started, we did not spend a lot of time in polar coordinates, I get. And the thing is, y from 0 to pi, if you work out what this is, let's just do it here, right? So multiply by r on both sides. R squared is equal to 2 r sine theta. That's what we get from multiplying by r on both sides. So this is x squared plus y squared. Wasn't planning on doing this, but let's just go ahead and do this, right? 2y is what we have, right? Y replaces r sine theta. So this is x squared plus y squared minus 2y equals 0 by completing the square, adding 1 to both sides. We have x squared plus y minus 1, quantity squared is equal to 1. So this is a circle of radius 1 with center at 0 comma 1. Now it turns out that, so this circle, it lives completely, in fact, so if the center is right there at 0, 1, and the radius is 1, then the circle actually lives right here. And it turns out that if you just run through values of theta from 0 to pi, you end up getting the circle once already. So you don't need to go any further than pi. And just how can I convince you of this real quick? Think of, when is the value of sine of theta equal to 0? Well, first happens when you plug in theta 0, and the next time it happens is when you plug in theta is equal to pi. So when theta is equal to pi, you've now reached the end, and when theta is equal to pi, so this way, right? How far do you travel? Well, sine of pi, or 2 times sine of pi, or 2 times 0. And so you travel a distance of 0, and so you end up right at the origin, right there. Okay, the region, then, that is enclosed, so this is just the circle itself, right? But the enclosed region is, so there's 1, there's 2. The enclosed region is the filled-in circle, right? It's technically called a disk. And so the region itself is going to be the set of all points of the form r theta, where theta, as we had already discussed up here, should go from 0 to pi, while r values, this was r equals because it was just the boundary, but now we need the inside, and it turns out this is going to be r starting at 0 at the smallest, because we've got points that are close to the origin, but going up to 2 sine theta. Okay, so then we'll set up the integral. I know that was a lot of discussion of the geometry here, but this integral over the region D, let's write that better, the double integral over the region D of this function f of x comma y dA is going to end up looking like this. Integral sign, the dA, as usual, becomes r dr d theta. Theta itself goes, as we see here, from 0 to pi, while r goes from 0 to 2 sine theta. 0, 2 sine theta. And then the function, right here, instead of writing this as is, we're going to write root 4 minus r squared. Okay. Now, the lucky thing is if we do a u substitution of 4 minus r squared, so u is equal to 4 minus r squared, things work out nicely because when you do a derivative, you get 2r, well, negative 2r. But morally, we can take care of this r here, right? So we'll have du is equal to negative 2r dr. If r, oh, what is going on here with the handwriting? If r is equal to 0, then let's see what u is. Then u, 4 minus 0 squared, is equal to 4. And if r is equal to 2 sine theta, if r is equal to 2 times sine theta, then u is equal to, well, 4 minus, and we just need to plug in 2 sine theta, right? So 2 sine theta quantity squared, so 4 sine squared theta. I know this is going to look a little messy, but here we go. Integral 0 to pi. Integral this u value to this u value. So 4 to 4 minus 4 sine squared theta. We work out all the algebra. I'll save you some of the trouble here. This is gonna, we've got to take care of the fact that there's a negative 2 here, etc., etc. We're gonna end up with negative 1/2 u to the 1/2 power du instead of a dr, and it's because of the du why these are u values. And then finally a d theta, still just copied from right there. Okay, so then this integral here ends up equaling integral 0 to pi. Now this integral's, nice to do, right? Because we just have to integrate u to the 1/2, so it'll be u to the 3/2 over 3/2. So here we go. Copy the negative 1/2 that's there. You've got u to the 3/2 over 3/2, which we need to evaluate at u is equal to 4 minus 4 sine squared theta, and u is equal to 4, and there's still a d theta to copy at the end. Okay, so then this will end up being integral 0 to pi of, here the 2's, see, this is a 2/3, right? So the 2's will cancel. We end up with integral negative 1/3. And there's some work here to work out, but you'll have here 2 times cosine of theta quantity cubed plus 1/3 times 4 to the 3/2 d theta. Okay, and we won't work out so much here because there's really, integrating a constant isn't going to be bad. Morally speaking, what's left here is to integrate cosine cubed theta, right? Because d theta. That's the only non-trivial thing. The rest is kind of just dealing with the correct constants and so on. So we'll just comment about this. That if you need to, do this integration here, what you're really looking at for indefinite integral is integral of cosine cubed theta, d theta. Just want to remind you of this trigonometric change that you can do here, and have cosine squared theta times cosine of theta, still a d theta. So that cosine squared theta that I mentioned, you can write that as 1 minus sine squared theta. Okay, and then the point is, what you can do here is do a substitution of u is equal to sine of theta, right? So that du is equal to cosine of theta d theta, and you'll work out that this integral would be 1 minus u squared, technically in parentheses du. Okay, and then there's steps here that won't be too bad. So I've left some details out, but I hope that sort of in terms of the key, the bigger, more challenging issues, they have been addressed here. I think the thing that may be a little challenging is actually just back here. Why is it really this? Why is it really this right here? So what I'd like to suggest for the interactive question is to do the following. I want to have you convince yourself that this works by doing the following things. So please pick a random value of theta in the interval 0 to pi. Okay? It doesn't have to be a nice number. It doesn't have to be pi over 3. It doesn't have to be pi over 6. Just pick anything, anything between 0 and 3.14. You can use a calculator for this, okay? And then, based on your chosen theta, okay, you might have picked theta to equal 1.1 or whatever. Then pick a random number r but not just any number r, and our number r satisfying that inequality earlier, that 0 should be less than or equal to r, should be less than or equal to 2 times sine of theta. So you should take your theta, first compute 2 times sine of theta, and then be sure to just pick an r value that's in between 0 and that number. Okay, then, based on the r and the theta that you chose, what point do you have? In xy form, right? So take the point that you have in polar coordinates and write it in rectangular coordinates, in xy coordinates. Then verify that the point that you have, the xy point that you have in this form, satisfies x minus 0 quantity squared plus y minus 1 quantity squared is less than or equal to 1. So that it really is a point, in other words, so that the point x comma y is in the filled unit circle centered at the point 0, 1. So if you do that, I think it helps clarify and put some credence behind the thing that was just kind of claimed up here. Finally, I really do want you to pick r and theta just kind of relatively randomly, as long as r satisfies this double inequality. Try not to pick a point that's too nice, because I think that then you lose kind of something to what's going on here. Go ahead and use a calculator. That's fine. And specifically, please pick theta first, and then pick r, so that you don't end up with, so that xy is not one of these following two predictable points, I guess. There's the point 0, 0, 0, 1, the point 0, 2, the point 1, 1, or the point negative 1, 1. All of these points were sort of very obvious points on this, in this filled-in circle, right? It's just the point that was in the middle, and then, go 1 unit each direction from there. So all of those points in the filled-in circle that have integer coordinates, those are these here, and that's just, there's sort of, I don't know, there's sort of a unclearness that then you may not be convinced. So I think by picking random numbers, you could be better convinced of what's going on here.